Hello, everyone. Thank you for coming to my talk. I would like to start off by thanking the whole ARM Research Summit Committee for organizing this event and for having me here. During this talk, I would like to introduce to you a social startup that I co-founded in 2018 called Majicom, that stands for the Water Community, as we use a co-creation approach with local communities to develop digital water ecosystems that supply affordable drinking water across urban Africa. Before I introduce Magicom, I want to take a moment to introduce myself. I am an experimental physicist and material scientist by training. I was born in Jordan, grew up in Canada. I've spent the last 8 years in Europe. Currently, I'm at TU Delft in the Netherlands, where I am using a very sensitive quantum sensor to probe and ultimately understand a new class of 2D magnetic materials to see if they can be used in next generation information technologies. Previously, I was at the University of Cambridge, where I finished my PhD last March. And there I fabricated materials to design sensitive data storage devices. And in my research, I solely focus on incorporating sustainable elements as part of the EU criteria of critical raw elements in my material choices. It was actually at Cambridge that I co-founded Majicom, which I will now start to introduce to you. So I hope that you enjoy my talk. To introduce the problem, globally, at least 2 billion people use a drinking water source contaminated with feces. Breaking down the various water sources into three main categories: safe water, basic water, and unimproved water. Safe water is water that is safe to drink and is locally accessible, for example, from taps, either private or public. Basic water can refer to water that is used for bathing, sanitation, and just general personal hygiene or domestic uses, but not to drink. And unimproved water is water that is contaminated, for example, with fecal matter. Unimproved drinking water sources usually stem from surface water, for example, rivers, dams, lakes, ponds, canals, for example. They can also come from tanker trucks or from small tanks or drums. Starting at North American and European level, we see that 95% have access to safe drinking water, and this is water, again, that is safe to drink and is accessible through taps. Globally, this decreases to 70%, where 10% don't even have access to basic water. And in sub-Saharan Africa, the problem is particularly acute, where now 20% only have access to safe drinking water. This is quite the problem, as you take one stat in consideration. We know that 2,300 people die daily from water supply-related diseases like cholera and diarrhea. Actually, diarrheal diseases kill more children than AIDS, malaria, and measles combined, and this makes it the second most leading cause of death among children worldwide. So it's quite a problem, and a prompt solution is required. African cities, the population growth is actually outpacing the development of the supporting water infrastructure. If we take Dar es Salaam, which is the city that we have done most of our work, and Dar es Salaam is located in Tanzania, is actually one of the largest growing cities in the world, with a 5.5% annual population growth rate, and it's projected to have a population of 13 million by 2030. This will further exacerbate their clean water supply needs and lead to unplanned settlements. For example, it will lead to hacked and abandoned pipe networks, which would lead to non-revenue water, where water is collected and not paid for, and this further reduces the funds available for maintenance. And this water infrastructure gap has led to a rapid rise of the single-use bottled water market across the continent. In Tanzania alone, 40% of the population rely on single-use bottled water, extremely expensive source of water, and creates a disproportionate economic burden on many. It's also very polluting, with 90% of the bottles going unrecycled. So to counter this problem, at Majicom, we are creating digital water ecosystems for urban populations, which we have co-created with leading academics, communities, students, and engineers in Dar es Salaam. We have so far designed a full kiosk system with a fiberglass enclosure. The bulb that you see in blue is removable and can hold various user interfaces and payment functionalities. The water is dispensed from the droplet down to reusable bottles, and the base is the water storage tank. Unlike other kiosks, we offer a unique purification toolkit, which is designed for use in resource-constrained settings. For example, in our purification toolkit, we have a purifier that harnesses sunlight to purify water through a process called photocatalysis. This enables our kiosk to operate at ultra low power and costs. We have an end-to-end digital system which ties everything together. It combines remote monitoring of usage and performance, revenue sharing, digital systems, and rewards for end users. We plan to roll out these kiosks through a franchising model where our first customers will be universities and schools. We are currently working with our Tanzanian partners to co-create bespoke solutions and being able to install these kiosks across various campuses in Dar es Salaam. We hope to provide students who are actually the ideal early adopters of technology with access to clean and affordable drinking water, and the university with a crucial revenue. To add to this, our research has shown that continued maintenance and support, in addition to an educational component, is very important to promote sustainable behavior and continued digital adoption for a longer period of time. To implement the maintenance and educational platform, we have been designing an app and dashboard component. And a big thank you to Nelson, who was our lead design on this and has also been helping us with our branding. Right. Now, I would like to shift gears a bit by speaking more about the co-creation and our engagement approach, as the technology itself is not very useful without truly understanding local context. So I've broken this down to three main components, the first being device testing, second being community engagement, and the third being kiosk design. Starting with device testing, slide shows you essentially how we started via academic research at the University of Cambridge, where a few academics, including some of the co-founders, developed a new photocatalytic material that was very efficient at purifying water under solar irradiation, and this material was later patented. Initial trials were done via powder format and also through small handheld devices in Tanzania during, I think it was 2 field trips where they tested these materials with heavily polluted freshwater sources, and it led to very positive results, which later was the basis of founding Majicom in 2018. Since then, the material science approach was continued, and we've been able to mobilize these photocatalytic materials and recycle glass using very simple kitchen equipment like microwaves. And then we have developed our Generation 1 device, which is a serpentine channel, which includes our photocatalytic sand, which we call our solar sand, where water is pumped through and allows light to shine and pathogens in the process. Since then, we have recently developed our Generation 2 model with the help of Dami, who looked into local manufacturing methods in Tanzania in his final master's engineering project at the University of Cambridge. We've been able to adapt our Gen 2 device based on local manufacturing methods, and this device is actually being tested currently in Islam as we speak. Now, moving on to part 2 of the co-creation aspects, to speak to you about our community engagement, specifically about a project that I led in 2018, where we recruited 9 Tanzanian students as interns. We broke them up into 3 teams, first being market research team, the second being the business development team, and the third being the prototype design team. It helped us essentially understand the local problem better and truly showcases our co-creation approach. We surveyed over 123 households, we spoke with local businesses, and we also worked with local innovation labs to understand how to best implement our purification solution. We concluded this internship program by organizing a conference where our student interns presented their findings, in addition to stakeholders, for example, BRAC, which is one of the biggest NGOs in the world, Bridge for Change, a youth charity, and Stick Labs, an innovation lab in Dar es Salaam. This was a very important meeting and gave us a lot of productive feedback to incorporate in our kiosk solutions. Now, moving on to part 3 of the co-creation approach, moving towards the kiosk build. We recently prototyped and fabricated the kiosk enclosure elements in the UK. We use MDF molds and glass fiber techniques in collaboration with Vasca Design to create the physical systems. We showcased these closures in March, actually this year, where we received feedback and physical designs of the overall look in Tanzania during several workshops. There were various people who attended the workshops, for example, students, vendors, water engineers, and community members. During the same field trip, we also tested digital prototypes that were assembled in Dar es Salaam. Specifically, tested 3 devices which were based on 3 different payment systems. The first being an SMS-based payment system, the second being an RFID-based payment system, and the third being a direct cash-based payment system. We also organized several workshops based on these payment systems to see what was preferable amongst the users. Another exciting collaboration that we have initiated was with the Nafasi Art Space in Dar es Salaam, as we have discovered that there is a resurgence in pride in African culture and heritage amongst young people. So we're currently working with local artists to design various kiosk and bottle skins to incorporate African culture and heritage. Reusable bottles with the first featured art will be launched very soon, so please keep tuned for that. Now, a bit about our team. I'm very happy to have been working with such a wonderful team. Mike and Jerome have been there since the beginning. Serena, Peter, and I have joined in 2018, and we officially formed Majicom together. Our colleagues in Tanzania, specifically Jessica and Jamila, have joined after the internship program in 2018, and they lead our Tanzanian operations. We now get into the awards and recognitions. It was nice to be recognized, specifically when you have a startup and you've been working so hard since the beginning. I recently won the Royal Society of Chemistry Emerging Technologies Award, and we also came third place at the Cisco Global Problem Solver Challenge very, very recently. Serena was recognized as one of the 21 people to watch by Cofinitive here in Cambridge, and we've also been featured in local Tanzanian newspapers. So to help bring forth advertising and our exposure in Tanzania. And we hope to build on our continued success and move forward despite obvious limitations imposed by the current pandemic. Now, I would like to summarize everything that I've spoken so far into a video that we actually submitted to the Cisco Global Problem Solver Challenge. So I hope that you enjoy this short video.
Karibu Dar es Salaam. Hapa Dar es Salaam maji ni tatizo la kila siku.
Maji yetu ya bomba sio uhakika, na hata pale yanapopatikana sio salama kukunywa.
Mara nyingi njia salama ni maji ya chupa ambayo kwa wengi wetu ni gharama.
Lakini pia huchafua mji wetu kwa chupa za plastiki ambazo tupo kwenye maeneo mbalimbali kama kwenye mito, kwenye mitaa na fukwe za bahari.
Ndio maana lengo letu sisi Majicom ni kuhakikisha upatikanaji wa maji safi na salama kwa bei nafuu.
Our digital water ecosystems are explicitly designed for use in urban Africa. Our approach is 100% focused on local communities.
We run design sprints and workshops to ensure our solutions get to the heart of problems.
We assess various water purification technologies with local universities.
We collaborate with engineering firms to ensure everything can be made locally and at low cost. Our unique purification toolkit uses technology designed for resource-constrained settings, including our sun-powered catalytic devices and ultra-low-power UV LED reactors. This is combined with an elegant and transparent digital water management, payment and reward system. We roll all of this into an automated kiosk that cleans, stores and dispenses affordable water. We are already working with local universities to install the first Majicom ecosystems across campuses in Tanzania. Our business model ensures the university receives extra income and students access affordable water. As we roll out across Africa, we will create solutions for institutions, vendors, and households.
So I hope that you enjoyed the video and my talk. To conclude, I just wanted to say that if you do want to get involved with Majicom, we're always looking for funding partners, tech partners, mentors. So if any of you or anyone in your network is interested, please do get in contact, and I have left my contact details on the last slide. Thank you very much, and hope you enjoyed.
Okay, well, welcome to the Q&A for this session for the talk on the Majicom technology by Sama. We have a number of questions that have come in through Slido, so thank you to those who've asked questions. It's also my pleasure that Peter Knight has joined us. Peter is the product lead at Majicom, and I'll give him an opportunity to introduce himself before we get into the questions.
Shall I introduce myself now?
Please.
Okay, thanks. Thanks a lot, Hugo. So yeah, my name is Peter Knight. I'm the product lead at Majicom. I'm a biochemist by background, so and I've sort of transitioned to materials chemistry and work part-time in the Department of Materials Science and Metallurgy at Cambridge, and partly for a company in Birmingham, focused on battery recycling, really. But I'm kind of a frustrated engineer in part, which is how I got involved in Majicom in the first place. I was asked to get involved in the early stages of the reactor design, and yeah, I've stayed with it since, really. So yeah, my role is to put in place the physical infrastructure of the kiosk as it stands at the moment, which has been quite a challenge.
Oh, sorry, I went on my mute. Thank you very much for the introduction. So I'm going to jump into the questions now. So the first question is from a colleague at ARM, James Myers, and he asks, what is the output rate of your kiosk, and is it variable with weather conditions?
Yeah, so that's a more complicated question than it might appear on the surface, because we've actually got three different. We're viewing the system as a modular system, and there's actually three different purification modules that you can plug into it. So the first purification system, and the one that really catalyzed the whole development of the system in the first place, is the photocatalytic system, and that's comparatively slow. The flow rates through the purification system there are comparatively slow, in the region of about 12 litres an hour or 0.2 of a litre a minute. So that's why the system that you saw some pictures of it, that's why we have water containers, water tanks, and all. It's one of the reasons why we have water tanks in that, because that's not fast enough for real-time dispensing of water, or it would be so slow it would annoy people. The other reason we have tanks is because water supply is not necessarily consistent. In other words, taps go off at times. But yeah, so for one of the purification systems, it's not fast enough at the moment. We have sped it up, but at the moment it's not fast enough for real-time dispensing. The other two systems are much faster. So there's a filter, a water filter system, which is running around about probably sort of 10 litres a minute, that kind of flow rate. And the LED system is, the sky's the limit, more or less. Many litres a minute. It's very fast. So that is certainly feasible to use that as a real-time dispensing system. So yeah, those are the dispensing rates. I suspect part of your question, I'm paraphrasing here, but I'm guessing part of your question is with a photocatalytic system. One of the things that we need to be cautious of is what happens as light intensity varies, which can happen during the course of the day. When you get the sun high in the sky, obviously the intensity falling on the reactor will be higher than when it's low in the sky in the mornings and the evenings. And also what happens if a truck parks itself in front of the photocatalytic the reactor, or something walks past it, or a leaf falls on top of it, and that is important. It does matter, and it's one of the reasons why the design that we have that incorporates the photocatalytic reactor also has a light sensor in the same plane as the reactor. So we're monitoring light falling on the reactor all the time, and we modulate. The idea is that we modulate the flow rate in relative to the light intensity falling on the system. And we actually trialed a version of that. We had some students at the engineering department of Cambridge that built us a fairly they only had 2 days to do it. It was part of their project, so it certainly wasn't an optimized system, but it was a system that functioned, and we actually tested it in Tanzania, and it does indeed vary the flow rate relative to the light intensity. So that is an important thing, or an important issue for the photocatalytic reactor, and it is something that we do have a partial answer to, and we need to refine that, and there is work in hand to do that now. I hope that answers the question.
Thanks, that's fantastic. The next question is about if you could please compare the approach to bottled water, and I guess this is about economics and pricing, and also I think you talked in the presentation about plastic waste as well, and that number just really blew my mind, the amount of plastic waste. So I'm going to just add on to the question that has been asked, and ask you to talk a little bit more about that as well, please.
Yeah, so the local research done by our local Tanzanian team, they've been able to discover that there is an awareness of the plastic burden that's causing to the environment. So there is a positive, essentially, change towards using more disposable, less disposable bottles and reusable bottles. So that is one aspect which we're currently trying to explore, which is why we are essentially working with Nefasti Art Space to design new water bottle designs to actually increase this adoption, and also incorporating high quality water bottles. In terms of cost, we're able to undercut the cost by 50% of the bottled water, giving incentive to our early adopters, which are the students, to actually have a cheaper water source. So that's something which we can provide as an advantage over the bottled water market. And we hope that that would essentially kind of improve the or decrease the amount of waste generated by the bottled water market.
That's fantastic, thank you. So there's been several more questions coming in since we've started this Q&A, which is fantastic. So I'm actually going to merge two of the questions together. That's really about reliability, durability, and maintenance. So what do you need to do to keep the kiosks running over time, and how reliable are they?
Yeah, so those are key questions, sort of really important questions. We don't necessarily have, so at this point in time, we haven't run a full, complete live system. We've run the purifiers separately, and we've had dispensing modules, but we haven't actually had an entire system running. And that's one thing that we're doing at the moment, is building an entire fully functioning system with all of the bits together. But in terms of in terms of the maintenance, I'm going to approach it in the reverse order. In terms of maintenance, one of the things that there's two aspects to this. Or at least two aspects to this. One of the problems that we foresee is, because we've got tanks in the system, water tanks in the system, one of the issues is contamination of the tanks. It's almost inevitable. It is inevitable. If you just leave them running, the tanks will start growing things. One of the systems we're putting in place in the water flow system side of the tank is a loop between the two tanks that allows us to cycle water. In fact, we can put a mild bleach in, clean the tank, cycle the water through, and get it out again. And that's important because using the Photocat system, we have to have both an upstream and a downstream tank. The upstream tank is taking account of intermittent water supply, inlet water supply, and the downstream tank allows us to do sensible real-time dispensing, which we can't do directly from the purifier. But that means both tanks are vulnerable to contamination, and we need a method of cleaning them. And indeed the tubing between them. So that's like one aspect of maintenance. Another aspect of the maintenance really relates to, or is the reason why we have sensors on we're monitoring sort of flow rate and tank capacity, because they'll give us an early indication of whether we've got problems, whether we've got leaks anywhere, whether there's an issue with the system, and we're outputting that information to or ultimately the fully designed system will output that information to desktop apps, which the operator of the machine will have access to, and the background operator, Majicom in this case, will also have access to it. So we can monitor our remote machines, and the vendor can directly monitor his or her own machine. So that's one aspect. So that's another aspect of the maintenance. In terms of longevity, so again, there's multiple aspects to this. Probably the bit that we're most concerned about in terms of longevity is the actual purifiers themselves, and there's three different purifiers: the LED, the filter, and the Photocat system. So the LEDs probably, at least in theory, have the longest life of the three different purifiers. I mean, they should run for ad infinitum, really. Both the filter and the filter itself, as distinct from the Photocat, the filter is prone to blocking. So we'll need to monitor flow rate to find out what the potential blockage, performance blockage of that is. And the other thing we absolutely need to have in the system is a pre-filter, so that we take out fines and particulates before they even get to the purifier system. The Photocat should be, to a greater or lesser extent, self-cleaning. So it has activity in and of itself. It should be killing anything that's trying to grow within the reactor. That's the just so story. In real life, we probably still will get a blockage, and so we'll still need to clear those blockages at times. We don't know yet what the life of those systems will be, because we haven't run them long enough. So we've got a long-term trial of the Photocat system in Tanzania at the moment, and the systems have been running since about February. So the end of March is when we initiated the system, and they're still running now, although there obviously was some interruption over the COVID period. So they've been running for months, certainly, but we won't really know, in terms of numbers, we won't really know the answer to that question until we've got more running time. What was the third part of the question? I can't remember. Sorry, Hugo.
I think we covered most of it. The other aspect was about mean time to failure and stuff like that. And I think you answered that just now.
Yeah. Okay.
And actually, the next question is related to that. Is what about sort of, I guess, security risks as well? So you know, vandalism, theft, that sort of thing. Can you talk about that?
Yeah, that is a concern, and again, that's sort of, there's many different things that play into that. So in part, this comes down to the likelihood of it being vandalized comes down to the payment system we use, and you know, do we incorporate a cash payment system? And a lot of the market research we've done suggests that that people like cash payment. It's the system that people habitually use to buy water on demand in Tanzania, specifically in Dar es Salaam. And obviously that does add you know, if you've got a box of cash in the system, that makes it a target for vandalism. So it is a concern. There's several reasons that we would like to incentivize people to move towards digital systems of payment, be that a mobile system or an RFID tag system. And at least one of those is security. Another one is it gives us the opportunity to bundle water, to offer people cheaper water if they buy a bundle package, but certainly it reduces our security profile. So what can we do about that? Well, at least it's I won't say it's nothing like the key driver, but it's one of the reasons behind we've pivoted slightly in terms of the first place the first area we're going to deploy the kiosk, which we're originally thinking of little shops, the stores that exist on the high street, or on the various high streets in Dar es Salaam. But we moved away from that idea really, when we're looking at a first deployment area on university campuses. We've got very close ties with Ardhi University, and we're working closely with with them both to develop the kiosk and develop a lot of the infrastructure around it. And that's a semi-secure, or a much more secure environment than on the high street. So we have inherent security, not total security, but inherent security by the environment we're choosing to first deploy into. In a street environment, it was intended to be used in a shop. So the kiosk itself would be in a shop. Obviously, the Photocatalytic purifier can't sit in a shop because it needs to be exposed to sunlight, so that would sit on the shop roof. But again, in that environment, you are still in a semi-secure environment. That's not to say that a gang couldn't break in and smash it open, but it would have to be at that point, they're probably going to go for the store till anyway. So
yeah. Okay, sorry, can I interrupt you on that one? I just want to get the last question in because I think it's quite an interesting one. And that is, have you considered the possibilities for data gathering? You're building effectively a network of solar sensors, and could there be an opportunity to perhaps finance part of the operation by selling that data or sharing that data in some way?
To partially answer the question, so we are looking into some sort of big data methods to essentially help us understand the current infrastructure gap within certain areas. And indeed, this would give us an insight on which areas would need the most help in terms of our solutions. However, we have yet to initiate such a method, and this is something that maybe one of the engineers at ARM could help with, and we can discuss further. Because I think it is a key point, and it would help us in terms of understanding the local context and the local situation a bit better. I'm not sure if Peter, you had anything to add?
So we're out of time, unfortunately, but I just wanted to thank you very much, Summer and Peter. That was fantastic, and thanks again for your presentation. Really interesting, and I think what you guys are doing is just fantastic. And I'd just like to add to amplify the point that you made at the end of your talk, Summer, which is that if you're local to Cambridge or Europe or perhaps Tanzania, then please do get in touch with Majicom and see if you can help out, because I think what they're doing is fantastic.
Thanks very much for the opportunity.
Thank you.